Welcome back. We hope you're ready for the next session dedicated to the Bricsys design-first path to building information modeling. Ladies and gentlemen, a very warm welcome to the BricsCAD BIM product owner, Timon Strobbe. Timon, the floor is yours.
Hello, and welcome to the BricsCAD BIM keynote session. Today, we will show you the latest developments to the BricsCAD BIM workflow, and you will see how we've partnered with best-in-class technology partners to deliver an amazing design-first BIM workflow. My name is Timon Strobbe, I'm a product owner at Bricsys, and I'm joined on stage by Jacob de Sutter, our BIM product specialist. The title of this presentation is an end-to-end BIM workflow that keeps design first. Let's explain what this means. As a team of architects ourselves, we are aware that the typical BIM design process is a broken workflow that involves multiple tools that do not exchange data in a consistent way. As a result, you spend a lot of time in manual, redundant, and repetitive work to create and recreate the deliverables needed in each phase of the building design lifecycle. It starts in the early design phase, when you create the initial model, and it continues as you add intelligence to your BIM and create the construction documents. It is our goal to deliver an automated end-to-end workflow for architectural design, construction documentation, and building product manufacturing. By leveraging automation, we let you focus on what you do best, which is the design of your building. We will walk you through this end-to-end workflow in this presentation. In the first part of our presentation, we will explain how in BricsCAD BIM you start with sculpting your conceptual design. Conceptual design is where we convert our ideas into a massing model to help us understand the project from a 3D massing view. Unlike traditional BIM tools, you can use intuitive push-pull direct modeling combined with parametric modeling, which is not limited by predefined parts or libraries of components. As a result, you can experience design freedom in a full 3D BIM workflow that will feed immediately in the BIM later in the process. An important aspect of the conceptual design are spaces. And let's hear from Miklos Svet, product manager at Bricsys, how you can work with spaces using a direct modeling approach.
Thank you, Timon. Enclosing space is the ultimate essence of architecture. Many stakeholders associated with the building throughout its life cycle rely on spatial information. Architects, MEP engineers, contractors, and facility managers alike. Consequently, spaces must become the backbone of a new generation BIM software. At Bricsys, we believe that users of a software need to have unlimited freedom to model any spatial geometry, just like how they can model any building element. Therefore, our spaces can be simple 3D volumes, or very complex ones, or even 2D abstractions. In addition to spaces, we also introduce story and building spatial elements in a hierarchical, IFC-compatible data structure. Spatial elements in BricsCAD BIM V21 feature many industry-first standout solutions. For example, generative building and spatial element authoring with the help of artificial intelligence, also known as quick building. Check it out.
Thank you, Miklos. Let's show what this massing workflow looks like. We can start sculpting 3D volumes to create the shape of the building that we have in mind. Jacob, can you explain to us how you create the initial shape of the building?
Yeah, so here I'm basically starting from a very simple box and using direct modeling tools such as extrude, push-pull, or by rotating faces. I am able to sculpt my way to an interesting design that works well with the project context. So here I am simply rotating faces, and I'm using the manipulator to help me with this process. Here I'm repeating the same process again to turn this model into a slightly more dynamic shape. Now, of course, next to direct modeling, it's also possible to use tools like, for example, scripting. Here I can use a Lisp routine that will slice this solid here into equal cells in the X, Y, and Z direction.
And of course, there are different ways to achieve this massing model or to create different volume studies. For example, you can import the geometry of the 3D volume from another tool or by using our Grasshopper connection to create it in a parametric way. In BricsCAD, you can work with native geometry or imported geometry in exactly the same way with no limitations. We can now use the structure tree to see that the cells which are created by the slicing algorithm are sorted by volume. So we can remove the cells with the smallest volumes to get rid of the partially sliced cells to achieve the shape that we have in mind. In this way, you can quickly create multiple volume studies, as you can see from the alternatives in this DWG model. And now, let's show a first example of automation. We're going to use a tool called Quick Building to transform our massing volume into an LOD 200 model automatically. Quick Building will shell the mass volume, and it will automatically create walls, slabs, and spatial elements like spaces, buildings, and stories. We can create a section plane to have a look inside the building. And we can indeed see that instead of a mass model, we have created walls and slabs. We can also go to the structure tree and isolate some of the slabs to see how the model was created. In this way, it is not only possible to compare design alternatives in a geometrical way, but also compare them using different derived quantities. As part of BricsCAD V21, we have introduced a new quantity framework that allows users to create configurable user-defined quantities. We have prepared some quantities up front, but of course it's also possible to create your own quantities using expressions like sum, max, or min. In this case, we are going to create a quantity for the compactness of the building. This can be calculated using an expression that divides the volume over the total surface area of our building shape. These kind of quantities can now be used downstream in the process, for example, for quantity takeoff, IFC export, or you can see them in the properties panel here on the right. What we have shown is a workflow to convert a mass model into a conceptual design model, with walls, slabs, and spatial elements. This can be used for evaluating design options, not only geometrically, but also with regards to quantities like compactness or floor-to-site ratio. In the next demo, we want to demonstrate a Scan-To-BIM workflow, where you can create a conceptual design model starting from a scanned point cloud. This is often the case in a renovation context. Last year at the Bricsys conference, we have announced a multi-year initiative to advance our Scan-To-BIM technology in cooperation with our partners HOK and Leica Geosystems. Our partners from HOK have delivered industry guidance that is helping us to create a solution that is able to handle large reality capture projects. And let's see what this workflow looks like in BricsCAD V21. We start here from an existing large point cloud of 98 gigabytes after processing of the point cloud. As you can see, the performance of this huge model is still very good. We can activate a section to have a look inside the point cloud, where we can see some of the bubbles. These bubbles are locations where the scan was taken. And we can click on such a bubble to see the exact scan that was taken from that position. From this bubble view, smart algorithms help the user to generate the 3D geometry she wants in one single click. And it also gives you feedback on deviations from the ideal model. Other algorithms later on can be used to straighten the model if needed. We can see that Jacob is now creating multiple planar surfaces to create the exact position of the room, and which can then be used for further modeling. Afterwards, we can use our native direct modeling tools like BIM Connect to finish the geometry of this room. Next to surfaces, it is also possible to detect solids, for example walls or slabs or columns, from the point cloud data. We can do this by choosing one point from where the solid should be created. What we are actually showing here is a semi-automatic workflow to create geometry from the point cloud that can be used later on to continue modeling or to convert them to intelligent BIM elements, as we will demonstrate in the next part of our presentation. In a similar way, we can continue to build the model until we have finished an LOD 200 model of the scanned building. As a result, we have a hybrid model of the point cloud combined with the geometry in the same DWG file. In the next part of our presentation, we will develop our concept model into a full information-rich BIM. BricsCAD BIM leverages the power of artificial intelligence to automatically convert your concept study model to a fully classified BIM. Before we go into that automation part, we would like to introduce the demo model that we will use during the remainder of this presentation, the Kentucky International Convention Center. It's a 9,000 square meter building with exhibit spaces, conference theater, meeting rooms, and a full-service kitchen. This model was developed in collaboration with our industry partner HOK to test the performance and scalability of the new developments in V21 in a real-life project. Let's first hear from Greg Schleusner, a design technology director at HOK, how Bricsys works together with industry partners like HOK to advance our future roadmap.
When we started working with Bricsys, we chose an existing project to reverse engineer, i.e., take a project we've already built, designed in other platforms, and rebuild that and use that basis of our work. So last year you saw the model reconstructed. This year you're going to see it used in demos. One of the main areas we focused on was drawing automation, and specifically we started with something like fire life safety, which is a lot of effort. So you can see here these kind of drawings are really laborious to produce, and so that was the basis of the collaboration. We think this way of working is a perfect process to go back and forth, to use the work that we've already done, and help engage and add to the development of Bricsys.
The first and foremost challenge with working with this kind of large-scale projects is, of course, performance. Our strategy to handle big models is very simple and straightforward, namely to split it up into smaller parts. It is plain common sense. You don't want to wait until the last duct or sofa on the 20th floor is rendered to check something on the second floor. You just open that model as if the rest didn't exist. Still, a large project remains a large project, and all these separate models are combined into one master model, which is often slow to open and handle when it contains a lot of large models. To address this, in BricsCAD V21, we have introduced background loading of XREFs. As you could see, we could open the large model in just a second, while all the nested submodels are being loaded in the background. Independent of the size and complexity of these XREFs, the master model opens instantly. The overall structure is displayed in low detail, while multiple processor cores are working in the background to load and render the XREFs in full detail. The XREFs show more detail as soon as it's ready, but before that you can already start inspecting data like the building and story information, or you can navigate through the project to that one XREF that you search for and open it up. Now that the entire model is ready, we will focus on a smaller part, namely the main mezzanine in the southwest part of the building, to show how we go from a geometric model to a BIM using our artificial intelligence tools. Let's open this model as a separate DWG file. If we open the structure tree in this model, we can see that it contains 410 solids. Now we want to convert these solids into information-rich BIM entities, like walls and slabs and columns. This would be a lot of manual work, and this is where a new example of automation comes in. BIMify is a tool to automatically classify these solids. It is based on machine learning algorithms that were trained on a large database of BIM models, and as such, BIMify is able to detect BIM types based on geometric attributes of the solids. BIMify will now start scanning the entire model to classify all the entities and also to detect buildings and stories and spaces. The goal here is that BIMify does the majority of the work, but as a designer, you can still overrule or change the classifications manually. For example, in the structure tree, we can see that there are building elements being classified. If we select them, we can see that, in fact, these are furnishing elements. So we can select these entities, we can go to the quad, and we can reclassify them as furnishing elements. Also from the structure tree, we can isolate, for example, the walls to see how the model is structured. And we can indeed see that BIMify has done a good job in classifying the walls. Jakob, can you now explain us how we can create and work with the new spaces in BricsCAD BIM V21?
So other than classifying objects according to its IFC classifications, BIMify also automatically created spaces in the model. So it automatically found all of the enclosed spaces, so enclosed by architectural elements such as walls, slabs, columns, and created space object for this. So you can see this here in a structure browser. I have here my spatial elements. Let me just isolate them. And you'll see that they're actually solid objects. So they're represented by solids. I can also represent them by, for example, footprints. So let me change their representation to footprint. This way, your model will be a bit less cluttered. And you can get a very clear overview of where the spaces in your model are. Of course, these spaces are also still linked to their enclosing entities, which means that, for example, if I would move a wall, let's say I move this wall here, you will notice as soon as I complete this operation that my two adjacent spaces here will be flagged as out of date. So you see this little exclamation mark. I can simply choose to update it automatically, and it will adapt to the new situation.
In order to increase the level of development of this model further, we can also start adding compositions to the walls and the slabs. For example, in this model, we can see several coverings for the structural columns. These coverings can serve as a fire casing. From the structure tree, we can easily select all the coverings, and we can apply a composition by drag and drop from the composition panel. After this is done, we can increase the LOD even more by applying details from our detail library. In this case, we want to apply a skirting board detail to the column coverings. This will improve the airtightness, but also serve as a protection for heavy objects. We can do this by drag and drop of the detail, and this will propagate the detail throughout the model. This means that it will scan and find all possible applications of a detail in the entire model by trying to find the exact same situations in the model where this detail can be applied. This saves you a lot of time, and it allows you to increase the level of development in the model consistently, not only in one single place. In this case, 128 applications were found, and we can manually select the indicators to choose whether to keep or ignore these details. So as a designer, you still have the full control. If we accept the changes, the geometric applications are applied directly to the solids in all the detected places. As a next step of automation, it is possible to use scripting in Python, which has a very high level and intuitive syntax for usage in BIM, without needing a lot of development background. For example, in this model, we are interested to see some key numbers about the model, like the occupancy of the rooms or the different areas of the different types of rooms. Using Python scripting, we can easily visualize this data using one of the many Python libraries that are available. For example, here we can see the results of the area and the occupancy analysis shown in real time from the BIM session, which gives us a lot of insights in how the model works. In this demo, we used a lot of artificial intelligence to automate tedious parts in the BIM workflow. Jürgen, who's a technical lead at the AI and R&D team, will now explain the vision for using artificial intelligence in BIM. Jürgen?
Thank you, Tim. You could say that about 80% of the time spent on a BIM project goes to labor-intensive, repetitive work, while only 20% is spent on actual design work. Think about all the BIM data that needs to be added to the model, about recreating details over and over again, and about annotating and perfecting all generated drawings. That is why our team focuses on the creation of intelligent design assistance tools that automate these repetitive tasks and give more time to the architect or designer to focus on what really matters, the design and the problem solving. We've already released a number of solutions that assist in creating a BIM model. You just saw examples of quick building, of BIMify and Propagate, but we also see opportunities for other improvements. Drawing generation, for instance, is something that typically still takes a lot of manual work to get exactly right. And also another interesting idea is the automatic checking of design requirements on your models. And of course, if you have one particularly hated bottleneck in your workflows, you can always let us know, and then we'll have a look at it.
Thank you. The next step in our workflow is to create the construction drawings that are incorporated in the tender documentation and the contract documents for construction works. Creating the documentation for a building project is often the most laborious and error-prone part of the architect's building design workflow. Our goal is to create clear and accurate construction documentation and give the user complete control on how the 2D drawings will look, including automation of tag placements and drawing customizations. Then, these automatically created sheets can be freely annotated and dimensioned using the 2D drafting tools that are available natively in DWG, while the drawing views stay in sync with the 3D model. Peter, a product manager at Bricsys, will now explain how the project browser can be used to create and manage your construction documents. Peter?
In BricsCAD BIM, the center of everything is a 3D model, created and manipulated using direct modeling. So the BIM is not built up from floor plans and elevations, but it is the other way around. The 2D is generated from 3D by calculating cross-sections and hidden line removal through the 3D objects. The resulting 2D line models are stored in separate DWG files, which can be edited using the standard toolkit for 2D drafting. And they are grouped using sheet sets. With the BricsCAD BIM project browser, in a couple clicks you can create a sheet set filled with hundreds of sheets, all using your company standard title blocks, page setups, plotter configurations, and naming convention. Floor plans, sections, elevations, and details are automatically laid out on the sheets. You can even create multiple sheet sets for different phases in the project or for different drawing representation types. Adding more sheets to your project will not make the 3D model or any of the individual sheets bigger or slower to open up or handle. Let's have a look how that works.
Thank you. So we start here from the master model of the Kentucky Convention Center. To generate the plans of this large building, section volumes were made that represent only a smaller portion of the model. These section volumes cut through different XREFs of the master and can be used both for checking the 3D model, but they are also the basis to generate the construction documents. Elevations and vertical sections were constructed in a similar manner, and as a result, the entire model contains more than 700 section volumes. Let's isolate one section volume that we will work on. As Peter explained us before, the 2D views are stored in separate drawings linked to the model, which we can open from the project browser. The project browser gives us a full overview of all the sections and sheets and models that are part of the BIM project. From here, we can open a sheet that was generated up front to show what it looks like, including view labels, title blocks, and grids. A large set of sections still needs to be placed on the sheets here. So Jakob will now show us how you can configure the sheet set layout to create all the sheets that we need for the construction documents.
So in the sheet set setup, we can navigate through all of the supporting sections, schedules, and sheets in our project. In the Sheets tab here, we can find previews of the sheets to be created, including some placeholder viewports to know where the views will be placed exactly. If I scroll down here, I can see that there's a couple of sheets with detail views. And in this case, there's way too many views on this sheet. So what I can do is I can go to the configuration tab here and just change the margin in between my drawings or my views. So we have a more nicely laid out view here. Now we can see the spacing is way better in between these views, and also automatically more sheets were created in order to fit all of the views. Okay, so let's create the sheets here.
Thank you. So this workflow allows you to work with hundreds of sheets at the same time and control completely what they look like. As soon as the sheets are created, they will start updating in the background. While the sheets are updating in the background process, we can continue working. For example, we can start annotating this drawing. In the first place, we can start adding some composition tags. Composition tags show you the different layers of the wall compositions or slab compositions that you have used for this specific entities. Of course, these tags are also completely customizable according to your company or drawing standards. Secondly, we can also add some spot elevation levels. Spot elevations show you the finished floor level of the entities that are being tagged. Finally, we can also start adding some dimensions. We can do that using the 2D drafting tools that are available natively in DWG. As a designer, you have access to a large 2D drafting toolset to finish the construction drawings as you like, while we make sure that all your work is kept in sync with the 3D model. So let's now focus on the customization of the 2D drawings. And Jürgen will explain the idea and goal of the new drawing customization framework in V21. Jürgen, can you please explain it?
Yeah, sure. So typically in larger projects, you'll have several 2D drawings all derived from the same 3D model. You'll have construction drawings, structural views, fire and safety documentation, etc. In order to avoid a lot of manual work when creating all these drawings, we developed drawing customizations. Those are a kind of templates that you create once and then reuse in all your projects. And in one such template, you can specify which entity in the 3D model gets which appearance on a certain type of 2D drawing. For that, you can create rules that filter out a certain BIM entity in the model based on any set of properties it may have. And then you can deeply customize how that entity is drawn on the sheet. In the end, this means that a lot of manual touch-ups to your drawings are no longer needed and that a lot of potential errors in the process are avoided as well.
Thank you. In this demo, we start from a sheet with two viewports of the same section result. The end goal is to create two types of customized plans, namely a life and fire safety plan and a space area plan. And we will do that using the drawing customizations as explained by Jürgen. Drawing customizations are closely linked to properties in the BIM, so we first go to the 3D model view. In the BIM, we have added information about fire safety properties. For example, if we select one of the walls, we can see in the properties panel that this wall has a fire rating of 1 hour. We can also go to the structure tree to show that the model is organized by fire rating. So we can see some walls with a fire rating of half an hour, 1 hour, and 2 hours. Depending on this fire safety property, we want to give the walls a different representation on the floor plans. In order to do that, the first step is to define the actual style definition. The style definition will define what the different types of lines will look like. For example, for walls with a 1 hour fire rating, we want to show the intersection fill in a red color. We can also control all the other line types here, of course. Secondly, we don't just want to override what the walls will look like, but also we want to change how components like doors show up on the floor plans. For example, on our plan, we want to indicate automatically operated doors using a special tag. We can choose specific symbols, like this AOD tag, to show up on our floor plans, and they can be specified in an external DWG file. The third step is to define the rules that map the properties to the specific style definition. For example, here we can see some of the rules that were created to map the walls and the doors to the customizations. Once all of this is ready, we can start adding these customizations to our viewports. For example, for this viewport, we will apply the life and fire safety customization. So if we have a look at the customized viewport, we can see that the colors of the walls are now according to the fire safety property. Also, when we look at the doors, we can see the automatically operated doors being tagged in a specific way. We also want to show you a second example of drawing customizations. We are going to start from the same floor plan, and we are going to add a second customization file which we prepared up front. In this case, we will colorize the spaces according to the function in the BIM. For example, kitchen, storage, or toilet. But basically, any property can be used here to customize the look of your 2D drawings, as this is a completely generic framework. One of the advantages is that the definition of customizations are external to the content. So you can use these customizations to different kinds of geometry. For example, imported geometry from Rhino, IFC, or native geometry. So you can create customizations based on company-wide standards and reuse them in different projects to make sure that all your drawings are consistent. So here we can see that the spaces have a dedicated color according to the function of the space, but also the walls are customized and have a different look and feel. So this floor plan now looks quite structured and easy to read. In the fourth part of this presentation, we focus on visualization. As an architect, you probably want to showcase your first design steps to your client. Last year, we announced a partnership with Enscape for real-time, high-quality rendering as part of the Bricsys collective. This year, we are very proud to introduce a new member of the Bricsys collective, Twinmotion, developed by Unreal. Let's hear from Belinda Erkan, a product marketing manager at Twinmotion, who will talk about the value that this new integration can add to our customers.
This partnership is going to bring the whole range of Twinmotion's real-time capabilities to all BricsCAD users. Twinmotion is part of Epic Games, the developer of the Unreal Engine, and Epic Games brings a wealth of knowledge and history within the real-time technology space, where we have been pioneering and continuously driving real-time technology advancements through the engine. So we are very excited to help leverage the power of BricsCAD's unique and smart feature set, with Twinmotion enhancing the architectural design pipeline. And one of the essential core features of Twinmotion is that you can skip the time-consuming import and export process, because with Twinmotion you can really rapidly bring CAD data or your BIM data over to Twinmotion through the one-click direct link synchronization, which will be a plugin inside BricsCAD, and it will enable you to easily import your files into Twinmotion directly. And then once you're inside Twinmotion, it's easy to learn and use, because Twinmotion was designed this way. It was designed to be simple and easy to use by combining this intuitive icon-driven interface, drag and drop assets. You have these beautiful one-click workflows, so you'll be able to get started quite quickly and be productive right out of the box. So overall, it's a very intuitive experience, and BricsCAD users can be excited about all these new ways of visualizing your data with Twinmotion, having the Unreal Engine as the underlying technology. You can create beautiful visualizations and animations with a really smooth user experience. So thank you very much, and we are looking forward to seeing you create such compelling stories.
Thank you, Belinda. We start here from the model that was created in BricsCAD BIM, and we will export the master model as a single file with all XREFs included. We will do that using the Datasmith file format. Datasmith is the most state-of-the-art format used to exchange data between all kinds of applications and Twinmotion. Jakob will now show how to create renders and animations in Twinmotion, starting from an imported Datasmith file.
So when importing the Datasmith files into Twinmotion, you will notice the same structure as in BricsCAD BIM will be used here as well. So you can find the same XREF names, the same layer structure, and also the same classification types such as walls and slabs. So it makes it very easy to navigate through your model that you already know from BricsCAD BIM. Twinmotion comes with a big library of textures and assets, which are actually very easy to apply. So for instance, I can very easily drag and drop a concrete material onto these columns, and you will see that they all get the same texture at the same time. Same can be done for glass, for instance. I can simply drag and drop this glass texture on this model, which makes it already look more realistic. Finally, it's also possible to add assets such as trees or other vegetation into my model. Let's now look at some animations and renders that we made with Twinmotion.
In the final part of our presentation, we will focus on collaboration. Of course, BIM is not just about working in isolation. It's about creating, sharing, and collaborating with project partners across the globe. So we need to make sure that everyone can work together regardless of their design platform. In BricsCAD BIM, we enable this collaboration through the use of open standards like IFC and BCF, which is the preferred way of exchanging BIM information. As a complementary workflow, also offer different interoperability possibilities with other BIM authoring tools like Rhino Grasshopper Connection for generative design, and now in V21 also with Revit through RFA and RVT import. Ruben, who's a BIM product specialist at Bricsys, will explain how we work together with Building Smart International to increase adoption of open standards in the AEC industry. Ruben.
That's right, Timon. We at Bricsys believe in the open BIM approach. That's why Bricsys is an international member of Building Smart, the organization that creates the open standards needed to make that possible. The first one is IFC, the open, software-independent file format used to share data-rich BIM models. With IFC, you can combine different models, an architectural one, structural, MEP model, and so on, coming from different modeling tools, into one federated model, where you can do quality checks, clash detections, and much more. BricsCAD BIM also lets you import IFC files. And what's amazing is that all the building elements are loaded as native objects. So you can not only view them, but edit them just like any other native object. That's what OpenBIM is truly about. No more closed systems, no more closed file formats. BricsCAD BIM is even IFC certified, which guarantees the quality and reliability of the workflow. But that's not all. In a typical BIM project, you also want to communicate efficiently on issues, change requests, and so on. From now on, you can do that with BCF, the BIM collaboration format. No more back and forth emailing trying to describe what the exact issue is. No, BCF lets you immediately zoom in on the exact location where the issue is, shows you who needs to resolve it and how urgent it is. We already supported multiple BCF platforms, and now we can add BIM track to that list. By fully supporting the open BIM approach and continuously improving both IFC and BCF support, BricsCAD makes collaboration easier than ever.
Thank you, Ruben. Let's have a look at an IFC and BCF workflow in BricsCAD V21. For this demo, we will start from one part of the roof structure of the Kentucky Convention Center that spans the entire exhibit hall. And we are going to show how you can use BCF and IFC to work with other partners in the building design lifecycle project. Using the Issues panel, we can connect to several BCF services, including BIM Collect, BIM Collab, or BIM Track, where we can see a list of all open issues that needs to be addressed. We can see that there is one issue about a missing connection detail between the beams, so we can click on this issue to go to the correct location in the model. To resolve the issue, we will propagate a detail from the Details panel. We have prepared a detail up front for a connection between steel beams with a plate and a couple of fasteners, and after drag and drop of this detail, Propagate will scan the model and it will try to find all the possible applications where this detail can be applied. After this is done, we can ignore or accept these suggestions. And in this case, we will simply accept all the 48 connection details. So if we zoom in, we can see that the detail has been added and the issue seems to be resolved. So we can add a comment in our Issues panel where we say that the issue has been fixed using where we say that this issue has been fixed. We can also add a screenshot and add the comment to the issue. A second part of the Open BIM workflow is working with IFC. In V21, we have worked significantly on performance and stability of IFC import and export, but we also added several new improvements, like import and export mapping. This allows users to map internal BIM types to IFC types, which gives them a lot more control over how entities are exported and imported to IFC. Jakob has now exported this model of the roof structure to IFC. Once this is done, we can open the IFC model in any IFC viewer, for example, in our Bricsys 24/7 common data environment, to see what the IFC model looks like. In V21, we have also added improved interoperability possibilities with other file formats, including Revit models and Revit families. In order to do this, we work together with the Open Design Alliance, who has built a BIM SDK to support interoperability with different file formats. Neil Peterson, president of the ODA, will now explain the vision of the Open Design Alliance regarding the BIM SDK.
Open Design Alliance is a not-for-profit technology consortium that develops interoperability solutions for the CAD and BIM industries. We partner with Building Smart International, to support open standards such as IFC, and we also provide toolkits for proprietary design formats such as Revit, Navisworks, and DWG. Today, I'd like to highlight our BIM RV SDK. BIM RV is a toolkit that provides standalone access to Revit files with no dependencies on the native Revit product. BIM RV allows any application to read, import, and visualize complex Revit models. Limited creation support is also available, with full creation support under development. BIM RV is a mature solution. It's used by dozens of commercial products, and it's supported by a broad and diverse coalition of BIM software vendors. To find out more about our mission and products, visit us at opendesign.com.
Thanks, Neil. To show the RVT functionality, we will start here from an empty drawing and import a Revit file of a typical office building. During the import, we are presented with different possibilities. We can import the file as an underlay in a reference workflow, or we can directly import the Revit data as native solids. Also, we can choose to filter the RVT data by view, categories, levels, or worksets. In this example, we will import the Revit data by categories. For example, here we are interested to import the floor plan layout without furniture, spaces, and certain flow terminals like light fixtures. We can easily do that by excluding them from the dialog. And then, after we press import, we can see what the import looks like in BricsCAD. In this version, only the geometry is imported, but we can use tools like BIMify to turn this geometric model into a BIM. Once the model has been BIMified, we can use the structure tree, and we can see that different BIM types have been detected. For example, we can isolate the walls here and see that the walls have been detected correctly. This new RVT functionality enables a workflow where you work together with other stakeholders or teams that work with RVT data. For example, you can imagine that in BricsCAD BIM you can start doing interior layouting by adding office desks and trying out different layout organizations directly on this imported RVT data. But of course, other workflows are also possible. We see that this new RVT import functionality is a complementary workflow to working with open standards like IFC. Regarding collaboration, a question that we get often is how BricsCAD BIM allows multiple users to work together on the same model at the same time. In V21, we have worked on a multi-user workflow that is based on Git versioning control and that works directly on DWG. Version control is a system that records changes to files over time so that you can recall specific versions later. It is a proven solution for collaboration well known in other industries like software development. It allows architects to collaborate with others across the globe, as every architect can check out files locally from a central server. The advantages are that everyone knows what everyone else is doing, and administrators have full control over who can do what. Also, it allows you to work with smaller models, so there is no need to download the entire model if you only need to make a small adjustment to one specific part. And it allows you to work offline as well as online on multi-user projects, so you don't always need to be connected with the cloud server all the time to work on a multi-user project. This new Git-based version control functionality is now available as a beta functionality in BricsCAD V21. In this presentation, we have shown several ways to automate parts of your BIM workflow. In the future, we want to continue to follow this direction and take away the error-prone and time-consuming parts. On the modeling part, we want to make it easier to increase the level of development of your BIM using tools like Propagate and Copy Guided, but also make it very easy and intuitive to do conceptual design. On the BIM part, we want to automate going from a conceptual model to an information-rich BIM model using tools like BIMify and the ability to create quantity takeoffs from your BIM. On the construction drawing part, we want to continue improving automation of dimensioning and annotations on the 2D drawings. We hope you enjoyed this presentation, and we are looking forward to your feedback on the V21 version of BricsCAD BIM. Thank you, and enjoy the rest of the Bricsys Digital Summit.